Welcome to the Hair Groom Brainstorm for the first iteration. The purpose of this video is to explore some of the nodes used to achieve the look of the first groom, as well as to understand their upstream node tree needed to make them work and uncover a few of the attributes that drive these nodes. In this brainstorm, I'm especially interested in talking about the use of volume velocity and point velocity and the role that they play in designing groom direction. Moving to this first example here of the point velocity, I'm just going to take a sphere and I want to grow out some curves using the hair gen node. This is simple enough. Now, if I want to use this guide initialize, I get some sort of results, but it is not clear how I got these results just yet. So let's compare this to what would happen if I had the same sphere, and if I was to give some normals and remove all of the primitives, so I just see the points, and then add on point velocity. In this example, I've already added in the trails by just clicking this little toggle here for this V. V is point velocity. This differentiates itself from volume velocity, which is actually called vel and would not be a point attribute. It would be in the VDB section. Okay, I can see that I have lines extending into space. Well, what does this mean? This vector here, x, y, and z, as I increase, the length gets longer. That would not happen with hair curves, but this, for the trails, this makes sense. But as I change any one of these components of the vector, I can change the angle in which these trails extend. This same effect is what we see here with this guide initialize. I'm just going to increase this wind amount. As I change any one of the components in the wind direction, I have that same effect. Now, instead of thinking of these guides as the same as the trails for the point velocity, I want to also think about the curve view, which is the measurement along the length of a curve and the points and where they fall in that length when running from 0 to 1. That combined with the wind direction is how the wind amount bends the root to tip of each one of these curves. So reducing this wind, I could see that yes, the curves are spreading out more, but this is because as you look closer to the roots are not bending with that wind. I'll continue to drag the slider a little more, and there we have it. So if you want to get curves that bend sharply with that wind and look similar to, say, the trails of a point velocity, then just drag the wind amount all the way up. Now, these are exactly like the trails here in this point velocity in that they are penetrating through. Here, I'll turn off this add node. And you can see that all those trails are just, even starting on this side, are just penetrating through the geometry. One of the benefits is, with this guide initialize, is that you can avoid this using a tangential to skin slider. Now, I'm going to attempt to replicate that with this wrangle in which I take the normals and combine them with velocities, and this kind of stops those trails from punching through the surface, but it also doesn't bend very well going along the tangent. So let's observe this guide initialize. And as I turn on the tangential to skin, now curves no longer punch through the front of that geometry, but also curves in the back have their tangent contribute to the overall direction, which is not going to be this wind direction anymore. This is a product of the two. So this blend helps tremendously for getting a more natural look. However, if we were to put any kind of object on the surface, like say such as an ear on the head, if we want to take a look at the scalp here, these lines are going to be using that same idea of that guide initialize. How do we get these to bend around? Well, you're going to need a third input, which is here, the skin VDB. And if you were to put a volume in here, though this is behaving similar to a point velocity, it will realize that these lines are penetrating through and it will bend around as well as follow the tangential to the skin. Now, moving on, I want to look at another idea of velocity and hair curves. I'm going to again start with the same sphere and growing out some hair with this hair generation node. I'm going to try to use the volume velocity, which is the attribute vel. The volume velocity is controlled by this node right here, volume velocity from surface. As it needs a volume to grow inside of, I need to prepare that upstream. So again, with this sphere, and then extruding out a surface while keeping the backside of that extrusion, I now have something that's like a shell right here. So it's not transparent, we can't see inside, but I'm also going to create a small polygon group or a primitive group, rotate around here. And the purpose of this group is the primitives used to create this shell can also direct which way the volume velocity will travel to reach those primitives. To see that happen in effect here, we have these divergence groups. That previous primitive group that I created here was called goal. And I just gave it that name just to make it easy to understand. And I have a divergence factor. So when it is a 1, we are going to try to push away from goal. This can go down also and become a -1, in which we want to drive towards. Imagine like a sink, like a pothole, you would fall into it. But if it was 1, it'd be like a hill, you would go around it to get away from it. So this extrude back, that was another primitive group created by the poly extrude. I have it disabled for now. But now I'm going to see what does the volume look like if we were to use the velocity, if we were to use this volume slice, in which we will cut through all the voxels and look at the trails. So this volume trail has been set to the velocity volume attribute of vel. Again, different from v, the point velocities. So here we are. I can see these trails as they move through the voxels. They have the information of X, Y, and Z, and they could travel through. They come to this area here. Well, where was that goal? Let's take a quick look again. The goal was on the opposite side. So we have, in the examples of these trails, all the velocity flowing out and to the opposite side. If I was to change the divergence to a -1, imagine this like a pit, things drop into it. Now all of these same trails are flowing from here through this volume slice demonstration and now to this side. Once again, looking at where that goal is, there it is. So that is what the volume trails look like with a 3D velocity. Let's see how that plays out with this Groom node called guide advect. Now with guide advect, we are going to be taking the inputs of what we've created from the volume velocity from surface. And similarly, Groom, which was came from this hair generation, follows directly through the surface and meets at that one area here. Now, for the purpose of this demonstration, I'm going to change that divergence to +1 on the goal to flow away from it. And there we have it again. All the length of these hairs is moving to the back. Now, you might have noticed something. The hair generation node, these hairs were not nearly the length as what we're seeing in this guide advect node. Why is that? Well, that's because we have some operations here. So I have it set to fill velocity field. But if I change it to constraint advection, now we have hairs that flow across the original surface. They do not punch through the surface, and they follow those velocity field attributes, and they move to the back while all maintaining their original length. Now let's think about this logically. What do we want to see if we were going to make this Groom here? Do I really want the hairs to all have individual length that is similar, or do I want the hairs in the front to be able to flow and reach almost all the way to the back at one point, while the back hairs also keep a fairly short length instead of exploding out off into yonder? Well, I think in this case, for this Groom, it would make sense to use the guide advect, not constraint advection, but to fill velocity field. So that's what I'm going to be doing when I work with the Groom. Now, just to go back and take a look at the sphere again, let's set it back from constraint advection to fill velocity field. We have it coming all the way down here. I'm going to put a clip node in similar to the volume slice so I can just see through the Groom. Yeah, everything is going through, but we also have this input for skin VDB to know where in the volume that we should not be able to travel through. So I'm going to add, with this resample node, a curve view attribute and then add some color based on a ramp that uses the curve view attribute. And yes, I can see the tips, no matter where they start, all have, pardon me, the roots, no matter where they start, all have tips that reach to one region in the back. And so this is going to be very useful for understanding the kind of design that we want to create with our groom using these hair generation nodes. I hope that the discussion of point velocity, which is not actually an attribute that comes into guide initialize, but is very similar with its vector in the wind direction, and the field velocity example, which in fact is an attribute that is generated here, as you can see by vel. I hope that the conversation of these two attributes is helpful in understanding the direction of hair groom in our first iteration. Thank you for watching.